Hey guys, today we are going to be going backwards from what we've been doing the past couple days in Unit 2, and that is we're going to write the equations from the graphs. So our goal today is how do I write an equation of a sinusoidal function given a graph. So remember, this is the general form of any sort of trig function, sine or cosine. C is your vertical shift, A is your amplitude, so how tall it is, B is your period, so how much did it stretch or shrink, and then D is your phase shift, where you're looking where is your first graph. So let's get started. First things first, here's your graph, and we need to write the equation of a sinusoidal function that would match this graph. So I left my general form hanging out over here. The first thing that I want to do is figure out all of these letters. So let's just go in alphabetical order, and I'm going to start with A. Okay, so A. First things that I need to figure out is where is the middle. So the middle right here is actually no change at all. So if I'm thinking about this is my sinusoidal axis and it didn't move. So my C is going to be 0 because I still have a sinusoidal axis at the x-axis. Once I know where my sinusoidal axis is, I can figure out how tall my graph is from that middle point up to a high point or down to a low point. So here's my amplitude, and that would be from 0 to 12 is 12. So that makes my A equal to 12. Okay, so next thing I'm worried about is my period, or my B. I already have A and C. I'm already trucking along. So what you need to do in order to find the period of this graph is to pick a point. Pick any point you feel like. So I'm going to pick this top point up here. And then my goal is to find the same point somewhere else on my graph to figure out how long it took to get to that cycle to get it done. So here's, we start, here it is. It's back at the same spot. So this right here is the length of one cycle. Here's my period. And so in this case, my period went from 0 to 480, so my period is 480 degrees. Okay, well, we remember though, back when we were figuring this out, and since, oh, I totally forgot to mention this guy's going to be in degrees, because if you look down here at the axis, you can kind of see either it'll tell you degrees, or you'll look and you won't see any pi's and stuff in there. So this one is in degrees if you need to make a note, and it'll usually tell you where it wants you to graph in. So when I was finding my period before, my B, remember, in order to get that value, I did 360 divided by B. Well, now I need to get B by itself because that's the one I care about for the equation. So I'm going to go ahead and either cross multiply or get this B out of the denominator. And then that's going to give me B times the period equals 360. Again, this would be 2 pi if you were in radians. I'm going to divide by the period and find out my value of B is going to be 360 divided by the period. So it's almost the same equation, well, the same expression that we used before. You just take 360 and divide by how long you know your period is. So in this case, my B is going to be 360 divided by how long it takes to complete a cycle, which is 480. And I can go ahead and simplify that down, and that would simplify to 3/4. Okay, so I've almost got I've got 3 of my letters done. Now I need to figure out D, which is my phase shift. Okay, because remember, I didn't have a vertical shift. So now I'm going to think about how I find that phase shift. So first of all, you have to decide what kind of graph you're doing. So since I have a sine, I'm going to go ahead and find where a sine graph starts. So remember, sine starts at a middle. So when I'm going to find a midpoint on here. So here's a midpoint. And remember, sine goes up when it starts. So this is a midpoint that would start my sine. Here's another midpoint that starts my sine. So I'm just going to go ahead and use that first point. So since I know that I have a midpoint starts right there, my D value would be negative 120 degrees. Now remember, you have a minus sign in there, so that's going to flip-flop your sign. So when I write this equation, I can write y equals 0 or just A. So in that case, it's 12 was my A times the sine of 3/4 is what we called B, and then x or theta plus 120. Okay, this is a great answer. Well, you know, if you don't mark out half of your thing. Oh no. This is a perfect answer. However, we already said there was another spot where my graph could have started. I could have had this graph say x minus 360. I could have had a d value of 360 degrees. So there are multiple correct answers for just the sine one. And then, what if I tried to write this as a cosine graph? Because you can. So if I was to write this as a cosine, everything is going to stay the same because my phase change, the only thing that's going to change is my phase change. So my vertical shift will be the same, my A will be the same, my B will be the same. It's just where you start that makes your graph different. So if I wrote this as a cosine graph, I got to find out what my phase shift is. And so remember, cosine starts at a high point and then goes down. So one of my high points could be 0, so x minus 0. I have another one over here. And so that would be x minus 480. I could also do x plus 480 because here's another high point that goes down. So what I want you to realize here is you can have many, many, many correct answers. The other thing we could do, just to, totally blow your mind, is we could write these as negative functions. Where if I was looking for a negative sine graph, so for instance, if I put a negative 12 in front, we know that sine usually starts at a middle and goes up. Well, if I start at a middle and go down, that would be an appropriate negative sine phase change. So then I could have x minus 120, or maybe x plus 360. So what I want you guys to recognize is that there are lots and lots and lots of correct answers. You can write them as sine graphs, you can write them as cosine graphs, you can also write them as negative sine or cosine graphs. Okay, so let's practice in radians. Okay, so this guy, again, is going to be in radians. Why? Because I told you. Well, actually, because we're going to practice doing this with different things. A lot of times it'll say degrees down in the bottom if it's degrees, and if there's no degrees, it's just going to be assumed to be radians. Okay, so my first thing that I'm going to do is just let's go left to right. So I'm going to have C. My C value, remember, is where my sinusoidal axis is. And so I can see right here, my graph did shift up, so my C is going to be 8. Because it went up 8. The next thing I'm going to do is figure out how far from the middle one of my high points is to my low points. So I'm going to go ahead, just find one of those humps. And I went from 8 to 18, which tells me that my amplitude is 10. And you could see if you went down, it would have gone from 8 to negative 2, which is a distance of 10 as well. So my A value is 10. Next thing I've got to do is find my period. So remember, we're just going to take from 2 points of the same thing. So for instance, right here to right here, this was one complete cycle, and then we're going to count up how far this was to get from there. So I went from negative 35 to 5. So that would get me 40 radians to get all the way across. Because remember, we have to take absolute value into account. Negative 35 to 0 is 35 distance, plus another 5 is 40 radians. So since we are in radians, in order to find my B value, I'm going to take my 2 pi instead of 360, divide it by my period, which I just said was 40, which would simplify down to pi over 20. So my B value is pi over 20. Okay, so those are the 3 values that don't change. No matter which function you use, whether you use sine or cosine, all C, A, and B are going to be the same thing. It's just D that's going to change. So let's go ahead and try to write this as a sine graph. So we're going to have y equals 8 plus 10 sine of pi over 20. And now I need to find my D values. So for D, remember, you're going to pick a point where it would have started. So if I'm writing this as sine, then I need to find a starting point where it starts at a middle and goes up. So this would be a great starting point right here. So I could have that D is negative 35. Or if I look over here, it goes also at positive 5. So when I write my equation, I could write x plus 35, or I could have written x minus 5. Okay, so both of those are 100% correct. So now if I wanted to try to write this as a cosine graph, again, nothing changes except for D, and I guess the word cosine. Okay, and so now when I look at this graph, cosine starts at a high point and then goes down. So here's a point where it starts at a high point, so we could have negative 25. Okay, or up here starts at a high point, goes down at 15. And so I could write either plus 25 or minus 15. Again, both of these are 100% correct. All you've got to do is make sure you read the directions and see, do they want it as sine, do they want it as cosine, or write whichever one you feel more comfortable with. Okay, one last example. So we have this lovely graph in here, and again, I will tell you it's in radians. Most of the time, they will tell you in your exam or in your directions. While struggling with words again. So again, just go left to right. So my C value, where did it go up to? C is now 7 because the sinusoidal axis went up. Then my A value, how high did it go up? So if I take a middle point and go up to a high point, I look and that went 1, 2, 3, 4. So if you notice, A and C values go with your y-axis. You're looking and you're seeing how high did it go up from 0. Then you're looking to see where is it from the middle to the top or from the middle to the bottom. So A and C deal with the y-axis, counting on the y-axis, which means that your B and D values are going to deal with your x-axis. So when I find B, remember, I'm looking for 2 points that start at the same spot. So we have, let's try these bottom ones. And so in order to figure out how far I went to complete one cycle of this graph, I went from negative 50 to positive 70, which would give me a distance of 50 plus 70 is 120. And so remember, when I'm finding my B value, I'm going to go ahead and take, since I know I'm in radians, 2 pi over 120, which gets me pi over 60. Okay, and now's the point when you need to decide, am I going to be doing sine or cosine? So if you're trying to find your D value, if I'm doing sine, I'm looking for a point where it starts at a middle, goes up. So right here at negative 20, or right here at positive 100. And then if I wanted to do for cosine, a point where it starts up and then goes down, so we could do a negative 110, or we could do positive 10, or you could even go over here and do positive 130. So when you write out your equation, y equals c, well, you know, I have a number for that now. Y equals 7 plus 4 times the sine of pi over 60, x minus, pick one of your D values, I'll do 20, and remember, switch the sign in there. If you wanted to write it as cosine, y equals 7 plus 4 cosine of pi over 60, and then x, and pick one of your ones you want. I'll just pick 10 because I have to write less, and either of those answers are correct. And again, there are so many correct answers for these. So remember, the first thing you want to find is you want to find how far up or down you went. Then you want to find how tall your graph got. Then you want to figure out how long did it go for, so what's the period, and then figure out what that B value would be. And then you need to find a starting value. There's lots of correct starting values on these. Okay, have a great night.